You know, in the world of programming, some learning tools are just different. They're more than just tutorials. They become absolute legends. Today, we're talking about one of the greats, a ghost from 1988 that's just been brought back to life for a whole new generation.
So that brings us to the big question, right? Why on earth is a programming tutorial from over 35 years ago, Jack Crenshaw's Let's Build a Compiler series, still a legend? Why do people on places like Hacker News still talk about it like it's this sacred text? What's the secret sauce here?
Well, the reason we're talking about it now is that this old classic just got a massive modern makeover. Someone has taken the time to meticulously translate the entire original series, keeping all the core lessons but updating it for the programmers of today. And when I say update, I mean the leap in technology is just huge. The original was written in Pascal, and it generated code for the Motorola 6800 processor. I mean, for a lot of new developers, that's basically ancient history. The new version, it uses Python and targets WebAssembly, one of the most modern and exciting platforms out there. That is a gigantic leap across the decades.
Okay, so this compiler starts with a really simple, clean little programming language that Crenshaw designed himself, called KISS. You can see an example right here. It's super clean, super easy to understand. It's just a little program calling a procedure. That's it. And from that simple little program, the compiler you build spits out this. Yeah, this is complex, low-level WebAssembly. This is the stuff a machine can actually understand and execute. And that transformation from the simple, human-readable code to this, that's the magic of a compiler. And this tutorial lets you build that magic with your own two hands. So, what's the first secret to why this thing is so effective? It's all about its hands-on, build-it-yourself philosophy. See, instead of using some complex automatic tool to figure out what the code means, Crenshaw taught you how to write your own parser completely from scratch. He did this using a technique called a recursive descent parser. Now, that might sound complicated, but the whole point is its beautiful simplicity. You basically just turned the grammar rules of your language directly into a bunch of functions that call each other. Back then, when everyone was using these clunky generator tools like Yak, this clean, direct approach was a total game changer for a lot of people. And here's the crazy part. Crenshaw was way ahead of his time. Years later, the biggest players in the industry started doing the exact same thing. As you can see here, GCC, the legendary compiler, actually switched over to a handwritten parser in the mid-2000s, and Clang, Apple's super powerful compiler, was designed with one right from the start. Crenshaw's simple idea ended up becoming industry best practice. Okay, so that's secret number one. Secret number two is its laser focus on practical results, not just dry, abstract theory. It's not just about how you build it, it's about what you build first. The whole philosophy is get to the good stuff and get there fast.
I mean, almost immediately, this tutorial has you generating actual working assembly code. And if you're an engineer, a maker, anyone who builds things, you know there is nothing more motivating than seeing your creation actually do something. That immediate feedback loop is just so powerful for learning. And this was such a breath of fresh air. Because, traditional university courses would make you spend weeks, sometimes months, on all the dense theory of parsing. By the time you finally got to the exciting part, actually making the computer do something, most students had just completely burned out. Crenshaw's tutorial just flipped that whole script. But like with any approach in engineering, this incredible simplicity comes at a price. There's a trade-off. The very thing that makes this tutorial so approachable also creates some real limitations, especially when things get more complex. The technique Crenshaw uses is called syntax-directed translation. And what that really means is that the compiler is generating machine code on the fly, at the exact same time it's reading your source code for the first time. It doesn't stop and build a big picture of your program first. It just translates as it goes. So let's break that down. Crenshaw's way is simple, it's fast, and it's amazing for learning. But modern, high-performance compilers, they use a multi-phase approach. They first build out a whole model of your code, something called an abstract syntax tree, or AST. This lets them analyze the entire program before they generate any code, which is way, way better for optimization. So with Crenshaw's method, making code that works is pretty straightforward. But making code that is fast and efficient, that's incredibly hard to do. And why is that?
Well, to optimize code really well, the compiler needs to know things like the types of all your variables before it starts generating code. And that simple translate as you go approach just doesn't have that big picture view. But even with those limitations, this 35-year-old Ghost still has so much to teach us. The core principles behind it are maybe more relevant today than they've ever been. So what are the big takeaways? First, simplicity is a superpower when you're trying to teach something complex. Second, nothing, and I mean nothing, beats building something from the ground up if you really want to understand it. Third, that feeling of getting quick, tangible results is one of the best motivators in the world. And finally, maybe the most important lesson for any engineer, every single approach has trade-offs. Understanding them is everything. You know, this was a simple idea from 1988 that ended up being way ahead of its time, and it's still teaching us these really profound lessons. It just leaves me wondering, what other elegant, simple ideas from the past are we overlooking that could help us cut through all the complexity we face in technology today? It's definitely something to think about.